creativity suffered from the fact that you gave people certain tasks, but you had no standard or criterion to judge whether what they were doing was really creative. For example, a standard task that's been used in some of that research is, tell us as many uses as you can think of for a brick. Well, some people can think of 5 uses for a brick, some people can think of 15 uses for a brick. But is the person who thinks of 15 uses for a brick more creative in any serious sense than a person who thinks of 5 uses for a brick? How do you know?
Hello, I'm Mujan, and this is Sail on a Beach podcast. This episode, about that report. In the last episode, I told you about this report that was published in 1959 by Rand Corporation. A report that almost entirely changed our view about creativity. Its authors, Alan Newell, Cliff Shaw, and Herbert Simon. Before getting into details of this report and the experiments they did to come up with their claims, let's hear Herbert Simon describing their work in 1992.
We took a different tack. We said, there are some discoveries which everybody agrees were creative. We have them in the history books. We have the pictures of the people who made them. That's our definition of creativity. If you have your picture in the history book, you did something creative, right? So then we said, we'll study those actual historical events. So we studied how Kepler got his third law. And then we built a computer program. We said, if we give this computer program the same data that Kepler had and the same problem that Kepler took, will it find Kepler's law? Well, the answer is yes. And then we took some people in the laboratory, students, and we said, if we give them Kepler's data about the distances of the planets and the period of the revolution, will they discover Kepler's law? And 4 out of 14 of them did, without knowing what they were discovering, just numbers, X and Y. Then we had material for studying the processes of creativity. And
does this sound convincing to you? A picture in a history book. It makes absolute sense that in 1959, when psychologists were still trying to define what creativity is and what creative outcome really looks like, Simon and his colleagues couldn't really study the creative process without defining what counts as a creative process. So they had to start from somewhere, but choosing prominent figures in the history of science seems a bit too convenient of an option for a group that already had a program that could simulate human reasoning. The answer to why they chose such an approach is actually there in the very first page of this report, where they wrote, "We felt the need for a clear idea of the overall requirements and aims of such a theory. We proposed that a theory of creative thinking should consist in completely operational specifications for the behavior of mechanisms that with appropriate initial conditions would in fact think creatively." It wasn't really the case that they didn't want to acknowledge the complexity of creativity as a concept. It was just they needed a very pragmatic approach because what they were interested in was mainly the creative process. So they needed to avoid what they called more dramatic and mysterious aspects of creativity. They were very explicit about this in the report. They said how utopian studies on creativity are depends on how broadly or narrowly one interprets the term creative. And in their case, they regarded all human complex problem solving as creative to make it less utopian and more practical. All they needed to do was to show that creative thinking resembles problem solving processes. Then they could easily justify the use of their already developed theories and programs to replicate creative process. They first start discussing the distinctions between problem-solving processes and creative thinking. Then they start explaining how logic theories solve problems and what sorts of assumptions are used to create this program. They also had a section on explaining why they think logic theory's problem-solving process is in fact creative. Logic theorist was one-of-the-kind program, and it was revolutionary in what it was capable of. Was logic theorist a creative thinker? Absolutely. But connecting it to creativity was a big stretch. So let's see how they justified it. They wrote that problem solving is called creative to the extent that one or more of the following conditions are satisfied. One is that the product of the thinking has novelty and value, either for the thinker or for his culture. That's exactly the definition we have for creativity today. The other three conditions are the more commonly known conditions of creativity. That the thinking is unconventional, that it modifies or rejects a previously accepted idea, that the thinking happens over a considerable span of time, so it needs high motivation and persistence. And finally, that the problem as initially posed are vague and ill-defined. So part of the task is to formulate the problem itself. But remember, the problem solving doesn't need to have all these conditions together to be considered creative. It just needs one of them. So whenever you claim that the problems urban planners deal with are all wicked and ill-defined, you're claiming that everything that planners do is creative. Right after defining these conditions, they have a section on vagueness of the distinction between problem-solving process and creative thinking process. They start the section by saying that a problem-solving process can exhibit all of these characteristics to a greater or lesser degree, but we are unable to find any more specific criteria separating creative from non-creative thought process. And this is the greatest exhibition of the nothing but attitude towards creativity. They're very well aware of the potential comments they might receive on their claims. The general theme of this report is that whatever you think it's not explainable or understandable about creativity is in fact understandable and replicable. Intuition, hindsight, unconventionality, these are all addressed in creating logic theorists. But how did logic theorists solve problems that could address all these? To explain this, they broke down the generic problem-solving process. There is a problem that you want to find a solution to. You try to understand the problem, then you generate some potential solutions. And then there's always a stage that you have to evaluate which of these alternatives are the most suited solution for the problem you're solving. This might sound very basic, but how they defined these steps was really revolutionary. In that time when scientific approaches were gaining popularity, the assumption was that you can always know a great deal about the system you're dealing with. You know how things are related, so you can analyze your problem and know what caused it. Their argument was that people don't really start with a full knowledge of a system when solving problems. What they have is the best guess about how things work, and it's always through the process of experimenting with different options that they gain knowledge about the system, and then they evolve their solutions. So something very unique is happening in finding possible solutions and evaluating which one is the best one to go forward with. So the problem-solving process looks more like going through a maze. That you start with a path and you reach a barrier and you go backward and then you choose another path until you find the right one. But every time you try a path and realize that's not the right one, you gain some information about the environment you're in. So in your search, you're not anymore starting from zero every single time. You already gain information about the problem you're dealing with through the process of testing and trying different paths. The difference was that in creating logic theories, they argue that it's always more efficient if you start from the end, which also fits very perfectly with their argument that you always have some sort of solution in mind. So you start with the end anyway. What logic theories was really good at was discovering proofs for theorems. But that wasn't exactly the only problem that they considered in developing this problem solving. The others were chess playing, musical composition, visual pattern recognition, and designing electric motors. They all had two things in common. The end result, or the expected end result, was pretty much known in all of them. And also, they were highly ruled processes. There is a limited number of moves a player can make in chess. Music composition has specific combination of notes that you can create. Having such a rule-based environment also means that by any move, you can expect a certain outcome. But that's not always the case in dealing with wicked problems or ill-defined problems. Also, if all that general theorists did was to prove an already proven problem, can it use to discuss the entirety of the problem-solving process? General theorist hasn't really found the problem itself. It simply solved it in a more efficient way. This could have been something that would have raised a lot of questions about their work, so they have addressed it in the report. They mentioned that although general theorist is not really starting from a very new problem, but in trying to solve that problem, has already found 3 different ones that can be used as a new problem to be solved. So in a way, although it doesn't start with a creative task, it does include all the stages of creative problem solving. How does this then explain intuition? For Simon and his colleagues, intuition was just the memory of various steps that one has already taken. So intuition is just accumulation of previous experiences and the ability to retrieve them in a right context. So when, for example, a chess player plays a very unconventional move and it ends with a good result, for someone who's not familiar with conventional chess moves, it might look as a very intuitive act. But in their framework, Simon and his colleagues say that it has to do with expertise and the fact that the player has a solution in mind that might take few steps more and might be unconventional, but that the grand scheme of things is already there in the player's mind. So it's not a random gut feeling, but rather a result of expertise and knowing way more patterns than a novice player. The other issue was that logic theorist was designed for efficiency. What it was good at was that it could search all these potential solutions in a very effective way. This is what is called heuristic search. They mention that a major function of heuristics is to reduce the size of the problem space so that it can be searched in reasonable time. Effective heuristics exclude those portions of the space where solutions don't exist or are rare, and retain those portions where solutions are relatively common. But creativity needed unconventionality. It wasn't about arriving at common solution, and it didn't need to be efficient. But they argued that that's not a problem, that they can actually manipulate how the system is searching through different options. So what they could do in the case of creative problems was to tweak a system a bit and make the system to search a common solution first. If at first you don't succeed, then try something counterintuitive or try something unconventional. So it wasn't about the nature of the system that wasn't capable of dealing with this type of search. It was just it needed a different configuration to reflect the need for creativity in the process. There's also a really interesting section on multimodality of creative practices. Reading through it feels like you're reading a commentary on generative AI. What they're discussing is that usually creative practices are associated with visuals and mental images. That representation of concepts matter in language and creative practices. They argue that there is a tendency to think of these as entities that we can directly relate to reality. They push against such understanding of metaphors. They say that whatever you create, there's some information encoded in these metaphors. So although they're unique in different cultures and although people have different interpretations of them, they can be encoded for a single system or a single person, and the problem-solving process would remain the same. There's so many other interesting discussions in this report that I would strongly suggest you go and read the report yourself. But I will just mention these lines they wrote as a good summary of what they aimed with this report and what they've achieved. They wrote, "Creative problem solving is mysterious because it's hard to see how needles are found in haystacks without interminable search. We have tried to dispel the mystery of the performance by exhibiting devices that are capable of narrowing search to a very small part of the haystack. In one sense, however, this only paused the mystery back. We can now regard the task of learning an effective problem-solving heuristic as itself a problem-solving task. In the next episode, I really want to tell you more about the people behind these experiments, why they were interested in these topics, and how much of what they were interested in was really a push from the context they were in. Herbert Simon, the father of design thinking, artificial intelligence, and bounded rationality, was a political scientist who specialized in public administration and municipal governance. Today, the conversation around AI is mainly about how these systems can have longer-term planning, how they can deal with strategic tasks. And you might think that urban planners would be the ones that have the most knowledge about this. If you go to any AI-related event today and introduce yourself as a political scientist or an urban planner, you would get weird looks. But in the next episode, by reviewing how Herbert Simon got interested in this topic, I want to argue how relevant these professions are to development of AI. This is my very first podcast making experience, and so I would appreciate any feedback on the content or the structure of the podcast. So please comment, share, and subscribe. See you next time.